Hello and what's up, everyone? Welcome to the Market Peer for Benchmark Review. Let's get into it. So first up, our first problem says farmers sometimes use grain piles shown below to store and harvest grain. So, grain like corn and things like that, they just put it in a big pile, and that's kind of how it looks like. That is a picture basically of a cone, right? Flat in the bottom where the earth is, and then it comes up to a point. You could do this on your table if you just pour out salt. It's going to look like the same thing, but smaller. It says if the grain pile had a diameter, now remember, diameter goes all the way across the bottom of the circle, of 50 feet, and a height of 12 feet. What is the volume of the grain pile? Keep your answer in terms of pi. So first thing we need to know is the volume of a cone. So what is the volume of a cone, right? And our formula to find that out is V equals pi r cubed, r squared, h over 3. Or in other terms, 1/3 pi r squared h. That's the way I'm going to write it. So if you went on Google and you Googled this, it would have came up that first way, but this is just the easier way to wrap your head around. So now let's just rewrite this in terms that we know. Well, it gives us our diameter, which is 50. So we know that our r is half of that, which is 25. So now we can plug everything in. We know our h is going to be 12. That stands for height. So there we have our variables. And remember, it says keep it in terms of pi. That means we're not going to touch this pi. We're going to treat it like a variable, like x or y. It's just going to stay at this side. So what we do write is we're going to write volume equals 1/3 times my r squared, which is 25 squared, times 12. And then pi is going to hang out at the end here. What we're going to do is we're going to go over to our trusty, dusty Desmos scientific calculator, right? And we're going to plug this in. 1 divided by 3, click out, times 25 to the power of 2. And I'm not showing this on my screen because we should all know how to do this by now. If not, ask your teacher. But go to desmos.com/scientific. And when we plug all this in, it gives us the following. It's going to say my volume is 2,500 pi. Remember, we're not multiplying by pi. We're not multiplying by 3.14. We're leaving that pi symbol there, right? And then we just need to figure out, hey, what is this? Well, it's feet squared. Or feet, cubed. Because we're doing volume. And there we go. We got our answer. Next up, it says Gerald has a punch bowl in the shape of a hemisphere. That's just half of a sphere. And it says 1 cup is equivalent to approximately 14.44 cubic inches. What is the maximum number of cups in the punch bowl could hold? So first we need to find the volume of this punch bowl, right? So we need to know what is the volume formula for a sphere. And our volume formula for a sphere is 4/3 pi r cubed. Now, nowhere here says in terms of pi. So this time we're going to multiply out by pi. And once again, we're given our diameter of this hemisphere, right? So there's 2 things we have to do here. 1, we have to find our radius. So our radius is going to be half of this, which is 10. And 2, at the end of finding this volume, we need to cut it in half. Why? Because my sphere's cut in half. We only have the bottom part of the sphere here. So we need to make sure we cut that in half. So let's plug in our values. We got V equals 4/3 times 3.14 times 10 cubed. And once again, we're going to plug this into our calculator. So once again, go Desmos 4 divided by 3, open parenthesis, 3.14. Close parenthesis, open parenthesis, 10, close parenthesis to the power of 3. And it's going to give me about 4,186.67. We're going to round it to. So we get 4,000. 1,186.67. But remember, we have to cut this in half by dividing it by 2 because we only want half of the hemisphere. So we take that number for 186.67 divided by 2, and it's going to give me, and once again, we're going to round, 2,093.34. Now, finally, in order to figure out how many cups we could fit in here, we divide by 14.44. And we'll get our answer. So we take that number, 2093.34, and we divide by 14.44. And we're going to get about 195 cups. 145 cups. My brain's just putting numbers in there. 145. We're going to make this like squigglies instead. Like this. And that means about. We've rounded it to get that number. We went to whole cups here. So actually, yeah, that's about the answer. Next up, find the volume of the composite space figure to the nearest whole number. So what we need to know about this is it's made up of two shapes. We have our bottom, which is a rectangular prism, and then we have our top, which is half of a cylinder. So we need to find two formulas. So first formula is going to be length times width times height. And that's for my rectangular prism. My top formula is going to be pi r squared h, which is my top here. But we need to divide this top all by 2 because it's half of it. And then we're going to add these two together once we find them. So my first volume, we're going to get 5 times 12 times 8. And my second volume, we're going to have 3.14 times, what's the radius of this top one? Well, if this is 5 millimeters, we know up here's 5 millimeters, but that's my diameter. So we want to cut that in half, and that's going to give me a radius of 2.5 because it's half of 5. We get 2.5 squared. And then my height, which is going to be this length here, is 12, just like this length. So we get 12. And now we just plug both these into our Desmos calculator. We have 5 times 12 times 8, and that gives me 480. And on my other side, we're going to get 3.14 times 2.5 squared times 12. And that's going to give me 235.5. And last but not least, we got to add these two numbers together. So we got to add 480 and 235.5 because these are a composite, which means two shapes put together. And when we add these, what do we get? We get 715.5. Whoops, 715.5. And if we have our units, it's going to be millimeters cubed. Boom. There's our answer. So we're just taking the two volumes, one of my bottom rectangular prism and one of my half cylinder, and we're adding them together. Next up, it says a right cylindrical vase holds 350 liters of water. The radius of the vase is 0.8 centimeters. What is the height of the vase? Round to the nearest hundredth of a centimeter. So the thing is here, we're given something in liters and we're giving something in centimeters. So let's first convert this liters to centimeters cubed. And how are we going to do that? Well, we could say 3.5 divided by this number right here, 0.001. We do 3.5 divided by 0.001. That's going to give me 3,500. centimeters cubed. And that is the volume. This is our volume. So we're starting out with our volume. So one thing we need to do is write, hey, what is the volume of this cylinder? Well, it's just like what we did on our last slide. It's pi r squared h. So pi r squared h. Now let's plug in the numbers we know. We know my volume. It's 3,500. We know pi, 3.14. Do we know my radius? Yes, we do. The radius is 8 centimeters. So I'm just going to label that off to the side here. R equals 8. So let's plug that in. R8 squared. And the one thing we do not know is my height. And that's what we want to find. So what we have to do here is we're not going to touch the left side yet. We're going to simplify my right side by plugging this little bit into a calculator. So what do I mean by that? Well, let's look. Here's my calculator. What we need to plug in is this 3.14 times 8 squared. And the reason we plugged that in the way we did is so now we simplify it. So we're going to get 200.96 h. Right? So on my left side, like I said, we're not touching it. That's going to stay 3,500. On my right side, we're going to get 200.96 h. And now, how do we get this h by itself? Well, we're multiplying our number times the h, so we do the opposite. We divide 200.96. We divide 200.96. They're going to cancel here, and we're going to be left with h. And on my left side, now we just divide. We do 3,500 divided by 200.96, and we get a number. This is where we need a note. It says round to the nearest hundredth of a centimeter. Hundredth place is our second decimal. So we're going to get 17.42. H equals 17.42. Now I'm just going to rewrite this over on the side, nice and neat. 17.42, and my unit is going to be centimeters. And since this isn't volume, it's not centimeters cubed, it's just going to be centimeters because it's a measure of a length, the height. And there we go, we got our answer. So next up, it says that we have a silo for storing grain. So kind of like the grain we had earlier. But now this one has a cap. We have a cylinder with a cone on the top of it. The cylinder is 500 feet tall and has a radius of 200 feet. The cone is 8 feet tall with the same radius. Approximately how many cubic feet of grain can we fit in the silo? Well, we have to do the same thing that we did before. We have to find the volume of each. So let's first find the volume. You know what? I'm going to give these headers. We'll say cylinder is here, and then my cone will be there. So for my cylinder, let's write the information we know. The height is 50. The radius is 200. For my cone, the height is 8. The radius is the same. Now let's write our volume formula. For my cylinder, it's r squared h. And for my cone, one second, I'm not going to lie, I forgot. So I look it up, and it gives me, oh yeah, just like we used before, 1/3 pi r squared h. So now we plug these things in, and just like we did earlier in the other composite figure, we will then add them. So let's plug our numbers in, and we get 3.14. And once again, this doesn't say in terms of pi, right? So we multiply by pi this time. My r is 20 squared, and my h is 50. So let's first find this, and then we'll go and do our other one. So all we have to do is plug this into our calculator. So we get 3.14 times 20 squared times 50. And that's going to give me 62,800. And on my other side, let's plug in our values. 1/3, 3.14. My radius is 20, just like the other side. And my height is now 8, a lot shorter. So we plug that in. 1/3 times 3.14 times 20 squared times 8. And now this one is actually going to give us a decimal, which we'll have to round. We get V equals. And we're going to round this to the whole number because it says approximately how many cubic feet of grain can it fit in the silo. It doesn't say a decimal. It says cubic feet. Just boom, straight to the point. So that means we go whole number, 3,349. And now what we have to do is add these two numbers. So we get 62,800 plus 3,349. And when we add these two numbers, we get 66,149. We get 66,149. And that is the volume of the silo. And this is going to be feet cubed. And there we go. Another composite volume problem. All right, our next one, it says Jessica created a model of an ice cream cone by combining the shapes of a cone and a hemisphere. Based on the dimensions shown in the figure below, determine the volume of the model in terms of pi. So once again, it says in terms of pi. That means we do not multiply by pi. And one thing we need to fix here is this should not be going along the side here. So we're going to scribble that out, pretend like it's not there. And what that is actually going to be the height of this cone, 13. And with that information, we could find everything else out, right? So we're given the diameter of this top circle, which is the diameter of the sphere or the hemisphere, and the diameter for the cone. So if that's the diameter, which is 10, that means our radius will be 5. And with these two pieces of information, my radius, which is 5, and my height, which is 13, we could find the volume of this cone and the hemisphere right there. So cone, sphere. Our volume formula for a cone is the same thing we've been using. 1/3 pi r squared height. And my volume for a sphere is 4/3 pi r cubed. And once again, we will not substitute 3.14 in for pi because we want it in terms of pi. So let's rewrite this. We get volume equals 1/3. We're going to move pi to the end. My radius is 5 squared times 13. And we get pi at the end here. And my next one, volume equals 4/3. My radius moves up. We get 5 cubed. And we leave pi at the end. Now, one thing we're going to have to do with our sphere, since this is a hemisphere, is we're going to have to divide it by 2 at the end. Right? So we're going to have to divide by 2 at the end. So first, let's plug in our cone to our calculator. We get 1/3 divided by 5 squared times 5 squared times 13. And we're not going to multiply out by pi. So this is going to give me, and we're going to have to round, right? And we're going to round to the whole number. So we're going to volume equals 108 pi. And then for my next one, volume, we plug it in, 4/3 times 5 cubed. Times, that's it, not times anything. Whoops. That's going to give me 166, but we're going to round up. 167 pi. Once again, we have to cut this in half. So actually, we could keep this rounded. We'll keep it round up. 7. When we round this in half, going to give me 83.5, which we're going to make 84 pi. And what we do now is we add these two numbers together. We got 108 pi plus 84 pi, which is going to equal 108 plus 84, 192 pi. There's our answer. On to our next one. The next one, it says, the figure shows a design of a greenhouse with a rectangular floor. The front and back sides of the greenhouse are semicircles with a diameter of W. A roof is a half cylinder. Consider greenhouse A with the floor dimensions. W is 32 feet and the length is 18 feet. For greenhouses of this type, which of the listed floor dimensions will have the total cubic feet of space in the greenhouse be greater than that of greenhouse A? So we need to figure out which of these will have a greater dimension than greenhouse A. So what we have to do is plug this into a cylinder formula and then divide it by 2. So the volume of our cylinder is pi r squared h, but we're going to make this 1/2 pi r squared h. And we're not going to multiply by pi here. We're going to put that at the end. We're going to do this all in terms of pi. So we could just plug things in. We're going to have 5 different formulas using each of this information, where our length is our height, and then we're going to take half of our width to use as our radius here. So when we do that, for my first one, I'm going to get 1/2, and that's using these two up here, right? This is going to be the one that we want it to be bigger than. This is going to be A, or greenhouse A. We're going to say it is half of 32 is 16 squared times 18. And that's going to give us an answer. And this is going to be the answer we want to beat. So let's plug this into our calculator. 1/2 16 squared times 18. That's going to give me 2,304. And we're going to just, pi at the end. Oops. Pi. 2,304 pi. And this is what we want to beat, because it says for greenhouse of this type, which of the listed floor dimensions will the total cubic feet space in the greenhouse be greater than that of A? So the next ones we want to be greater. So we're going to do them in different colors just to kind of keep everything separate. So for A, we just want to plug things in. We get volume equals 1/2. Half of our 30, which will be 15 squared, times 19. And we'll leave pi at the end. So we plug this in. If you're on Desmos, all you have to do is erase the 16, make it into a 15. So let me actually show you. So if we're on Desmos, this is really easy. All you do here is go 15. And then here, 19. And there we go. We got our answer right here. So now we could just put that in. And we could do that for each of these. We could just change the answer right there, and then it's going to give us our answer. So this one's going to give us 2,137.5 pi, which is not bigger. Next color. Green. Once again, we just substitute things in. 1/2 times 15, which is half of this 30 here, squared, times 20 pi. Once again, in our Desmos calculator, we just change the numbers we need to change. And this is going to give me 2,250. Still not bigger. Next up, change the color. Where's my cursor? Right here. We'll go blue. V equals 1/2. Now we're doing half of 20, which is 10 squared. My length, which is my height here, is 11 pi. I could already predict, since both these numbers are smaller than the others, that this is not going to work. So let's just plug it into our calculator by swapping out the numbers just to be safe. 10 and 11. Like I said, smaller. This is going to be super small. This is going to be 550 pi. That's not what we want. And my last one, which has to be our answer here. Oh, I forgot to underline C. Just a color coordinate. And our last one, the volume is 1/2. We do half of 36, which is going to be 18 squared, and then 15 pi. So this one has to be bigger. Let's find out if it is. It's going to give me, 1 second, let me just plug it in. 18 and 15. This is going to give me 2,430 pi. So which one's our right answer? It's this last one right here. Oh, I can't make it straight. There you go. I'll just go above and beyond. There we go. There's our answer. Next up, we have a density question. Now, this one's going to be a lot easier than we think. It says we can use the formula for density is mass over volume. So we get D equals M over V. To find the density of a substance, a square metal has the density of 10.2. So D equals 10.2 grams per cubic centimeter. And the mass of 37.93 kilograms. Now, here's the problem. We need to convert kilograms to grams. And the way that works is we just multiply this by 1,000. Right? So we multiply that by 1,000, which is going to give us the mass to be 37,930. So now we just plug this stuff in. And what do we get? We get 10.2 equals 37930 over my volume. And the way we could flip-flop this around is when we have a problem that's set up like this, where we have a constant equals a constant over a variable, we could flop my variable with that constant on the other side of the equal sign. So something like this. And we just solve that to get our answer, which is going to give us 37930 divided by 10.2. This is going to give us 3,718 point, let's round to, for the 10th, 6. And this is going to be centimeters cubed. And there's my answer. Next up, it says 3 of the great Egyptian pyramids are pictured below. Each is a square pyramid. Calculate the missing information for each of the 3 individual pyramids based on the given measurements. So, for the first one, the Great Pyramid, Menkaure, has a height of about 210 feet and a base side length of 330 feet. What is the volume? Well, for a square pyramid, we need to find our volume formula. Which is going to be the area of the base squared. Oh, sorry, the area or the base edge squared time. Sorry, I'll just write it out. Sorry for the confusion. Our volume formula is 1/3 S, which is the side length, squared H times the height of the pyramid. So, for my first one, we're going to make 3 different sections here, right? And we'll do 3 different colors. So, purple will be number 1. right? What is our information that we know? The height is 210. And the side length, S, 330. We want to find our volume. So we plug it in. We get V equals 1/3, 330 squared times 210. And we just put this in our calculator. We get 1/3, 330 squared times 210. And that gives us a big number. The volume of this pyramid is going to be 7,623,000 feet cubed. And that's our first answer. Problem number 2. We'll do in dark blue. It says this pyramid, the pyramid Khafre, has a volume of about 74 million cubic feet. Obviously, look at that. It's bigger. So we're given, we'll do number 2 here. This is the volume is about 74,400,000 feet, right? The side length, S of 330. Same side length this one, just taller. What's the sorry, I looked at the wrong thing. Whoops, base side length is 700. I got my lines mixed up. It's not the same. Also, let me make this closer. Side equals 700. Or else we're going to run out of room here. What we want to find is our answer. Or we want to find our height. So once again, we plug it in using this formula. Now we know our volume. So we get 74,400,000 equals 1/3. We know our side length. It's 700 squared. Then we're looking for H. So we need to simplify here. So in my decimals calculator, I need to do 1/3 times 700 squared. Right? And that's going to give me 74,400,000 equals 163,333. We're going to round this to 0.3. And now we just divide both sides. That gives me 74,400,000 divided by 163,333.3. And that's going to give me a height of about 455.5 feet. That's that answer. And my last one. A lot of work for one problem. Once again, now we're given the volume of our last pyramid, Khufu. The volume is 86,700,000. And my height is 450 feet. And what we need to do for this one, once again, we plug it in. We get 86,700,000. 86,700,000 equals. We don't know our side length. So I'm going to put that at the end. We're going to plug in H, 450. And we're going to get S squared at the end here. So once again, we need to combine this. 1/3 times 450. That gives me 150. So what do I get? I get 86,700,000 equals 150 S squared. We divide both sides by that 150. We get 86,700,000 divided by 150, which will give me 578,000. That's a lot of math. Big numbers. 578,000 S squared. Now we got to take the square root of both sides. We could get S by itself. So put it in my calculator. 578,000. And we get about 760.3 feet. And there is our final answer. We did all three of these little problems within this problem. Next up, it says the figure shows a plane slicing through a cone. The plane is neither parallel nor perpendicular to the base of the cone, and the plane does not intersect the base of the cone. What shape does it give us? Well, when it's not parallel or perpendicular, it's going to give us a shape that's almost like a circle, but not, and it's going to be what we call an ellipse. So our answer here is C. It's like a stretched out circle. That one was easy. Next up, this is a rectangle will be rotated 360 degrees about a line that contains a point of intersection of its diagonals. Whoa. And is parallel to the side. What is the three-dimensional shape that will be created as a result? So let's draw out our picture. We have our rectangle. Our diagonals look like this. The point is in the middle here. Now it says that this line is, it says the intersection of diagonals that's parallel to the sides, right? So what does that mean? That this line is going, let me draw the line in a different color. If it's parallel to the side or to a side, doesn't really matter, I guess. If it's parallel to a side, that means it's perpendicular to the others. This line has to be going like this, which means when we rotate it around here, right, as this side comes around this way, and as this side comes around this way, that's going to give us a cylinder. There's our answer. Next up, we have a new problem. It says the number of people who live in a unit area is called the population density of the area. It is usually given as people per square mile or per square kilometer. A map of Orchard Hill neighborhood is shown. The population of Orchard Hill neighborhood is 360 people. The length of each block is the same, and the length of 20 blocks is 1 mile. What is the area in square miles of Orchard Hill? Well, if 20 blocks is 1 mile, we need to find out what 1 block is. So 1 block is going to be 1 over 20, which is, as a decimal, 0.05. So 1 block is 0.05. So here we have 3 blocks up. So we go 1, 2, 3, which is going to be 0.15. Here we have 4 blocks to the right, which is going to be 0.2. So now it says, what is the area in square miles of Orchard Hill? All you have to do is multiply these two. 0.15 times 0.2. So this problem is supposed to be more complicated than we expect. Which is going to give me 0.03 miles squared. There's our answer. So our next problem, it says Hank is putting jelly candies into 2 containers. One container is a cylindrical jar with a height of 36.3 centimeters and a diameter of 7 centimeters. The other container is spherical. Hank determines that the candies are cylindrical in shape and that each candy has the height of 2 centimeters and the diameter of 1.5 centimeters. He also determines that the air will take up 20% of the volume of the containers. The rest of the space will be taken up by the candies. After Hank fills the cylindrical candies, what will be the volume in cubic centimeters of the air in the cylindrical jar? So the thing about this problem is they give you way too much information you don't need. because all it wants to know is the air in the cylindrical jar. So we need to know two things: the volume of the cylindrical jar and then how much air. So the air is 20% of the volume. So now we just need to know the volume of the jar, right? So we don't need anything about the candies. So all this is no good to us, along with a lot of other stuff, like the other spherical container. That doesn't matter. So all we have to do is find the volume. And our volume formula here is for a cylinder, which is pi r squared h. Now, we know that pi is 3.14. My radius, well, we're given the diameter. So we have to cut that in half. So we get 3.5 squared. And then my height, which is 36.3. So we get 3.14 times 3.5 squared times 36.3. And we get the volume of the entire jar is 1,396 point, let's say 28. And what we then need to do is multiply this by 0.2 or 20%. And that's going to give us the volume of air. V of air. So the volume of air, right? So let's multiply that. We get 1396.28 times 0.2. And that's going to give us about 279.256, right? But we want to round to the whole number, so we're going to get 279. And there's our answer. Next up, it says for Spirit Week, a high school club is making wristbands from paper. The wristbands are designed to have the height of 3.6 centimeters and a maximum diameter of 15 centimeters. How many square centimeters of paper are required to make each wristband? Round the nearest answer, or round the answer to nearest tenth. So we have to think about this. The wristbands are going to be made out of paper, right? And this paper is going to be in a rectangle. So we need to find the area of what this paper needs to be. So the very first thing we need to do is find not the volume of a circle that we're going to have here, because the wristband is going to look something like this if we look down at it, right? It's going to be a circle. So what we want to do is actually find the circumference. We need to make sure we have our circumference formula, which is 2 pi r. So we're going to get our circumference is 2 pi r. Now, what is my r? Well, we know our diameter is 15, so we have to cut that in half. So we get our circumference as 2 times 3.14. And my radius is going to be half of 15, which is 7.5. Let's multiply this out. And when we do multiply this out, we get 47.1. So our circumference is 47.1. And what that actually means is if we have this rectangle, right? Pretend like this is this strip of paper. If we wrap this around our wrist, it would make a circle. So this length here is actually the length there of our wristband. And then 3.6 is the side. So now in order to find the area, we just multiply those two numbers and we get our answer, 47.1 times 3.6. It says round to the nearest tenth. So this is going to give me 169.6 centimeters squared. Next up, it says the equation X squared minus 6x plus y squared equals 11 defines the circle in the xy coordinate plane. Find the center of the circle and the length of the radius. And we want to rewrite our equation in standard form. So in order to do that, let's rewrite this equation. We get x squared minus 6x. They're already next to each other, which is great. We're going to leave a space here because we're going to have to complete the square. So we're going to get plus y squared equals 11. And in order to complete the square, we want to take this number here, this negative 6, right? So we get, negative 6. And we divide it by 2, which will give me negative 3. And then we square that to get 9. And that's what we're going to add here. But we also want to add it to both sides. So now we could rewrite this and simplify a little bit. Now, this is going to factor. This chunk here will factor. And we're going to get x minus 3 squared plus y squared equals 20. Now, if we remember our standard formula, it's x minus h squared plus y minus k squared equals r squared, which means that my center is h comma k. So here we have an h, which is 3, and since it's negative already, that means we take the opposite, and we're going to have 3, comma, and we don't have anything with my y, which means that's going to be 0. And my radius here is going to be the square root of this number right here, 20. There is no simple version of the square root of 20, but we can simplify this by thinking of it this way. The square root of 4 times the square root of 5, which is really equal to 2 square root 5. So this is our answer. The center is at 3, 0, and our radius is equal to 2, 5, or square root of 20. Same thing. Next up, we have another equation. So we just want to write it in the proper form. So once again, we want to put this in our standard form. Now the problem is we have to rework this a little bit because our equation looks like this. X squared plus y squared plus 12y minus 8. That's all fine and dandy, but this isn't a perfect square trinomial. So what we want to do is add 8 to both sides. And this is going to give us x squared plus y squared plus 12y. We're going to leave a space where that 8 was, equals 8. And we want to fill that space in by completing the square, just like we did in our last one. So we're going to take our number here, 12. We're going to divide it by 2, which give me 6. And then we square that to get 36. And that is what we're adding on both sides. Now we could factor this. Yeah. So we get x squared plus y. And this is going to be what goes in here. It's going to be plus 6 squared equals, and then we just have to figure out, hey, what's 8 plus 36? Well, that's 44. And now it says, what are the value for k, and what is the value for c? Well, in here, the value for k equals 6. The value for c is equal to 44. There's our answer. And that is the end. Finally, I know it's a lot of information, but we did it. Good job for sticking in there. If you have questions, comments, or concerns, please let me or your teacher know. But thank you for watching. Make sure you take the notes, and good luck.